Hi everyone, we are in a very difficult situation with this COVID-19 crisis. And I want to wish you all a lot of strength. But we see right now that in the USA and other places in the world, our leaders are mainly focused on the medical impact and also on the economic impact of this crisis. That is understandable. There is another dimension that is also important. That is the dimension of the technical and the engineering part of the equation. Our buildings, whether it's a hospital, a nursing or elderly home, a prison, or any other type of commercial buildings, were simply not designed for a level of contamination we see right now with the COVID-19 crisis. If we are to fight and win this monster, we need an all-hands-on-deck approach. And what I mean by that is that all disciplines need to come together and work in a holistic way. Our leaders need to bring coherent message with the health and the well-being of people in the center. Hi, my name is Aniaro Pinas. I'm a holistic engineer and inventor with 30 plus years experience in renewable energy and also in indoor air climate. Today, I want to talk to you about mitigating the problems with the COVID-19 crisis from an engineering perspective. It's well known that the air inside our building is a lot more polluted than the air outside, especially now with the COVID crisis. I've prepared a couple of drawings for you to show you and to illustrate the importance of the indoor air climate and the air pattern in our buildings as it relates to the viral load and the bacterial load in our buildings. Let's go and look at them. Before we jump into the drawings and look at the options of adapting our HVAC system, let us first look at what we know about COVID-19. Here is what we know. The disease is called COVID-19, but the virus itself is called SARS-CoV-2. It's a novel virus, which means that we don't know much about it. And the size of the virus is only 0.125 micron. It is very small compared to a dust particle with a size of 1 to 100 micron. Studies have shown that the COVID-19 virus likely remains airborne for some longer time than we initially thought. This has serious consequences for the way we design our HVAC systems now and in the future. ASHRAE, which is the American Society of Heating, Refrigeration and Air Conditioning Engineers, has looked into this and they come up with the following statement. Allow me to read it to you. Transmission of SARS-CoV-2 through the air is sufficiently likely that airborne exposure to the virus should be controlled. Changes to the building operations, including the operations of heating, ventilation, and air conditioning systems, can reduce airborne exposure. Now, what is the takeaway of this? The takeaway is that we should revisit our buildings, HVAC systems, how we design them, and how we adapt them now during the COVID pandemic and in the new normal afterward. Let's start by looking at the proper ventilation rate to begin with this process. Ventilation rate is expressed in air changes per hour according to the ASHRAE standards. That is the amount of times the volume of a room is replaced and circulated through the HVAC system in 1 hour. This will depend on the functionality of the room. For example, if we have a patient's rooms or an intensive care unit, we need at least 6 air changes an hour, of which 2 air changes should be outside air. If we talk about the isolation room, we will need a minimum of 12 air changes an hour, of which 2 air changes should be outside air. With an operation room, this is a lot higher. Then we're gonna need a minimum of 20 air changes an hour, of which 4 air changes should be outside air. Let me look what is going on now with the COVID-19 situation. In our buildings, whether hospitals or nursing elderly homes, we see that COVID-19 patients are often in rooms with 3 to 6 air changes, and that is low. Rooms with COVID patients should be treated like isolation rooms and should have at least 12 air changes, of which 2 air changes should be outside air. Better yet, at least 12 air changes with 3 to 4 outside air. Now let's start with different adaptations that you can make to your HVAC system to mitigate the problem with the COVID-19 crisis for now and also for the situation we call the new normal afterward. Let's start to look at actions that you can take immediately right now without huge intervention to your system. At first, you can surface and disinfect our air handler systems immediately. Air handler systems and HVAC units are a source of contamination. A lot of dust and particles, as well as viruses and bacteria, can accumulate in our air handlers, especially in the drain pan. Another thing that we can do, we can have a higher surface frequency of our air handlers. What we also can consider that is very important, installing UV lamps in the ducts coming from the air handler to the conditioned space or in the room itself, a room with COVID-19 patients. So these UV lamps help to kill off the viruses and bacteria. What we can also do is install mobile HEPA filters and UV filters. These we can install in, or we can just place them in rooms with COVID-19 patients. And we can also install high quality HEPA filters. These filters we normally install in the supply grills or in the duct, supply duct, to avoid particles to come into the conditioned space. And we can also install them in the return duct to avoid contamination, viruses, bacteria, dust from the living space to go to the air handler again. Another important thing is in rooms with COVID-19 patients to create a laminar flow in the rooms and avoid turbulence as much as possible. What is also important, if you have a room with infectious patients, for example a room with COVID-19 patients, it's important to have a negative pressure in the room. And how do we do that? A negative pressure we can do in different ways. The most important thing is that we take out more air out of the room compared to the air we bring into the room. For example, if we bring into the room 850 CFM, we should take at least 950 to 1000 CFM out of the room. That means 10 to 15% more air we take out of the room compared to the air we bring in the room. This creates a negative pressure in the room. There's another way to do it, a more professional way, that is with differential pressure sensors and controllers, and then you can control the air supply and exhaust from the room, to and from the room. This last one, increasing the fresh air amount to the room, for example a room with COVID-19 patient, is extremely important. What happens a lot of times is in air handlers, they close off the fresh air intake or reduce the fresh air intake or the amount of fresh air coming in. This to reduce energy costs, but that is dangerous, jeopardizing our health. And especially in this time with the COVID-19 pandemic, it's important to bring in as much fresh air as possible. Now, let's look at a traditional HVAC system to give you a better idea of how the system works and how we can adapt those systems. Here we have a traditional system with HVAC unit with 10 to 15% fresh air. The air is conditioned in the HVAC unit and is going to the ceiling diffuser. The air is dropped into the living space and is moving through the living space. And while it's moving through the living space, it picks up contamination like dust particles, bacteria, carbon dioxide, viruses, and it moves back. As the air heats up, it starts to rise. That is normal. Air that is being heating up is starting to rise. So with the contamination, the air moves toward the return grills that are in the ceiling or high in the wall. This rising air with contaminants in it is a risk for medical personnel to get infected. So this is something we should look at, especially in a system with recirculation, because contaminants are accumulating in the living space because you only recirculating the air and cleaning only part of the air. Let's look what happens if we lower the return grills. We can see here a return grill that has been installed low. You can immediately see that the air pattern has changed. The air that is coming from the ceiling and is moving through the living space stays low. So the contaminants in the air like dust particles, VOCs, carbon dioxide, bacteria, and viruses, they move with the air low toward the return grill, which is better for our nurses and doctors and all other medical personnel. Is better and it's lowering the risk of infection. A note on these adaptations, they can be temporary. For example, if we look at the wall grills, we can install a temporary partition that take care of the return air. So with a temporary partition, we see that the pattern of the return air with bacteria and viruses is changed. The air is staying low and is going up, rising behind the temporary partition or temporary duct, and is going to the return grill. So the system remains the same, but the air pattern change. What is better and is reducing the risk of infection. If we have ceiling returns, for example, what we can do is disconnect the main return duct and install the duct on temporary low return grills. Let's now take it a step further and install fan filter units in rooms with COVID-19 patients or other critical rooms. You can see in the drawing that the ceiling diffuser has been replaced by fan filter unit. These units are dropping the air in a laminar way in the living zone. You can see the air is moving through the living zone and picking up contaminants and is rising toward the high ceiling or high wall returns. This is a risk, but as the air is circulating, it's being cleaned by the fan filter units. So that is an advantage. Let's look what happens if we lower the return grills. We can see right away that the air pattern has changed. The air is dropped into the living zone and the air moves through the living zone, picking up contaminants, bacteria and viruses and other contaminants and moving to the low return. This is an advantage because the air is low and the risk for medical personnel to get infected is lower. Let's now zoom a little bit more into the fan filter units and what are their advantages to use them with your retrofits. Here you have a fan filter unit with two most important items or components are the HEPA filter inside and the fan. The HEPA filter is to clean the air and the fan inside is to take care of the pressure difference across the HEPA filter. So that are the two most important parts. You also see that you have this perforated grill that take care of a more laminar flow toward the living zone. Let's now look at the advantages. These fan filter units can give you a higher amount of air changes in a room. They also secure the proper air quantity to your room, so you're sure you're getting the proper amount of clean air to your room. Another advantage is that they give you a more laminar airflow, as I just mentioned. Let's now look at the retrofit options. At first, we see here that we have a ducted option. There we see that the ducts from the HVAC unit is connected to the fan filter units, and then the air is dropped in the living zone and recirculate. The second option is a ductless option. There we see that the duct from the HVAC unit is going to the supply plenum, and from the supply plenum air is going to the fan filter unit and to the living zone. The last option is an interesting one. There we see recirculating of air. Here we can increase the amount of air changes in the room. What's actually happening is that the air from the room, the contaminated air, is going through a low return and going back to the fan filter unit and is filtered. So the air is circulating a couple of times through the fan filter unit and cleaning the air from the room. Now we're going to look at adaptation to our HVAC system by introducing more fresh air in our buildings. And to understand that, we need to look at a short history. Let's go back to the 50s and the 60s. If we look at a building style, we see that the buildings were less airtight. There was a lot of infiltration and outside air was coming in. Actually, the buildings were leaking, and it was standard practice that the buildings were being ventilated with natural ventilation. A few decennia later, in the 70s and the 80s, we saw that there was more focus on aesthetics and also increasing air tightness of the buildings. There was insufficient attention, however, for proper fresh air ventilation rates. Then we move up to the 90s, the 80s, the 90s, and there we see that there was more focus on energy efficiency of homes and buildings, and also increased focus on sustainability and energy efficiency. That moves up even more when we start to build passive homes and zero energy homes. There was a red thread, and still is, and that is that there was insufficient focus, and there is insufficient focus on health as it relates to our home and our buildings. And what we see is that we had a problem with increasing amount of building-related respiratory illnesses like asthma and allergy. We call this problem the sick building syndrome. That's why it's important to introduce more fresh air in our building to enhance the indoor air quality and health of inhabitants, and also to dilute the polluted air in our buildings and to rid the building of pollutants inside. Pollutants like carbon dioxide, moisture, VOCs, bacteria, pollen, and also viruses. It is also important that fresh air is increasing the productivity of the inhabitants in the building. Now let's see what's going on with the COVID-19 pandemic. We see that in our building right now, it's very important to introduce more fresh air, especially in our hospitals and nursing homes, in our elderly homes, in prisons, and in all other buildings with high risk. In my upcoming book, Transforming the Energy World, I dedicated a special chapter called The Truth About Indoor Climate. There I go more in depth on this topic. Let's now look at the air pattern in a traditional HVAC system with a 100% fresh air energy recovery unit. Here we can see the traditional HVAC unit, and unit number 2 is a 100% fresh air unit. Both installations are integrated, and a very important piece of duct is this duct, where we have 2 dampers, so you can have the fresh air coming in and mix it with a little bit of return air. So we can choose a very high percentage of fresh air coming in and going to the living space to the ceiling diffusers. Here, the air is dropped in the living space and it is a high percentage of fresh air, so the contaminated air in the living space is diluted and the air with the contaminants is moving toward the high return grills. As this air has a lot of fresh air and the contaminated air is highly diluted, the percentage of contamination in the air that rises to the high grills is low. So the risk for medical personnel to get infected is low. Here you can see I highlighted energy recovery because as a renewable energy specialist, I highly recommend to use energy recovery units when we are buying fresh air units. The reason why is for higher efficiency of our systems, but also for the planet. Let's now look at another system with a 100% fresh air unit. Here we can see again that the fresh air unit is in the system, but here the fresh air unit replaced the traditional HVAC system or the HVAC unit. Here we can see the fresh air coming in and is cooled or heated by the 100% fresh air unit, and then it moves toward the ceiling diffuser. From the ceiling diffuser, the 100% fresh air is dropped into the living space. And as a lot of fresh air is dropped into the living space, the contaminated air in the living space is getting diluted at a high level. And the level of contamination is very low because of the dilution of the air. So the air then rises to the high return and doesn't form high risk for medical personnel because of the very low concentration of pollution in the air. And then the air is moving back to the HVAC unit and then exhausted through the special exhaust that is separate and far from the intake of the fresh air unit. Let's now look what happened when we lower the return grills. We can see once again 100% fresh air unit that is climatizing the air that's coming in, and the air that's coming in is rising again through the duct going to the ceiling diffuser, and the fresh air is dropped from the ceiling diffuser in the living space and dilutes the air in the living space as it is 100% fresh air. So the air with a low level of contaminants is now staying low and moving through the return grills, where the air is exhausted through a special exhaust, and that is far away from the intake of the 100% fresh air unit. Finally, let's look at two scenarios of makeshift field hospitals, and first start with a hospital with a recirculating system. Here we see a traditional HVAC unit that supplies the air through a duct, and in the center of the area we have textile duct that drops the air very silent in the living space. The air is coming back to the unit and get recirculated again. This unit has only 10 to 15% of fresh air. This is not the ideal situation for COVID-19 patients, especially when they are very sick. So that's why we have the second scenario where we have a 100% fresh air unit that is installed for the makeshift field hospital. We can see the fresh air is coming in and get conditioned by the unit, and we blow the air in, and through the same duct the air is introduced in the living space, and the exhaust air with all the contaminants is going back to the unit and get disposed of through an exhaust duct. So this is actually a very effective system to work with. We have seen and looked at different options to adapt our system. So let me give you a small recap. First of all, we looked at a traditional HVAC system with high return and ceiling diffusers. Then we looked at the same traditional HVAC system where we lowered the return grills and we see the pattern change. Then we looked at a situation where we replaced the ceiling diffuser by fan filter units and a low return. Then we looked at a situation where we introduced a 100% fresh air unit with energy recovery. We looked at another option with a 100% fresh air unit that replaced the existing HVAC unit. And finally, we looked at two systems of makeshift field hospitals, one with a recirculation system and another with a 100% fresh air unit. In order to compare and contrast these options to help you decide which option is more applicable for you, let's look at the following table. In the table, I've estimated the level of effectiveness and energy efficiency as well as the cost of different options. I use 1 as the lowest score and 10 as the highest. We have used a traditional HVAC system without any measures to benchmark. Here we see that the level of effectiveness and energy efficiency is relatively low. And as we add on different elements to the HVAC system, we see the level of effectiveness and energy efficiency increasing. There is a trade-off, however, in cost as we add on different interventions. I added a downloadable copy of important elements of this presentation on my COVID blog, so you can have it as a handy reference. As a final note, let's talk about some elements to consider when you're retrofitting with energy efficiency and renewable energy in mind. All new investment should be in line with the new green economy, or better yet, in line with more sustainable blue-green economy. What we see that traditional 100% fresh air units only are focusing on fresh air. The units we talked about in above scenarios are 100% fresh air units with energy recovery with an energy efficiency of 70 to 90%. These units reduce the infection risk for healthcare workers, and patients are also protected. On top of that, the units reduce energy consumption and greenhouse gas emission. In summary, we talked about easy-to-take measures to your HVAC system. We also talked about how we can adjust our existing HVAC system to lower the risk of infection for medical personnel and also to protect patients. We talked about focusing on fresh air rather than recirculation, and also about adapting the air pattern by lowering the high return grills and use low return grills to lower the risk of infection. The above measures are not too complicated or costly, but they do require technical and engineering intervention as compared to the quick measures that you can take right away. This is important, however, to fight the COVID crisis now, but also to plan for when we are opening the economy again, so that our buildings do not add to the problem, but become part of the solution. Let me conclude by giving you my URL of my blog. There you will find a lot of information, and also the downloadable PDF. I promise you, we are in a very difficult period here in the USA, but also abroad. That's why I'm offering my voluntary support to engineering teams in critical areas such as hospital, nursing and elderly homes, prison, and all other hard-hit areas. Feel free to reach out to me. Send me your drawings and I'll be glad to look at them and think along with you. We are all together in this and we will come through this together. Be safe and stay well.